7.5, day 2, focusing on solving exponentials and logarithms along with some application problems. Go ahead and write this topic down. All right, we're going to continue solving problems like we did in 7.5, day 1, where we want to find out what can x be. So one way to solve this logarithm of base 4 is to rewrite it as an exponential. Or we can use the inverse property that we learned. So I'm going to raise both sides to the 4th power. So what happens is this 4 raised to the log base 4, what I'm circling here are inverses of each other. So now we're just left with the left side of just x squared. On the right side, we have 4 raised to the 7th power. Now we can go ahead and use our calculator. 4 to the 7th power. So remember, you go 4, little caret symbol, and then 7. And we get 16,384. Now we would use our undoing of the x squared. So to undo an x squared, you square root both sides. So we get the square root of 16,384. And we get 128. We do not want to have a negative value here, so it is 128. So remember, we had a domain restriction with logarithms, so it should just be a positive. The next example is a little bit more challenging because we have 2 logarithms. So we want to use our property that says if 2 logarithms are adding to each other, we can combine them with multiplication. So the first thing is we'll combine these 2 logarithms together. So they're both log base 10. So we multiply 5x times x minus 1. So 5x, x minus 1, combined into one logarithm. And then the right side is still the same, 2. Now we want to remove that log base 10. So we're going to do the same thing as the last example. We're going to use the inverse property. So we're going to raise both sides to the 10th power. We do that to both sides. And then 10, log base 10 undo each other. So we're just left with, on the left side, 5x, x minus 1. And on the right side, we have 10 squared. Now we'll continue solving for x. So I'm going to distribute the 5x through to that parentheses. So we have 5x squared minus 5x. On the right side, 10 times 10 is 100. Now we have a quadratic equation, so we want to factor it and set the factors equal to 0 and solve for x. So I'm going to bring the 100 over to the left side. I lost my word connection here. So I bring the 100 over to the left side and set it equal to 0. Now I factor, so I'm going to take out a 5 from all 3 terms. So I'm left with x squared minus x minus 10. Now we can go ahead and factor this trinomial. If you remember the t-chart method that I taught you, what are the factors of negative 10 that add to negative 4? Well, that is negative 5 and positive 4. Now we set each factor equal to 0 and solve for x. So each factor is x minus 5 and x plus 4. Now we undo and we get 5 and negative 4. Again, with logarithms, we just want the positive value. Let's go on to the next example. Very similar to the one that we just did. We want to notice that these both have a log base b on the left side with an addition symbol. So we can combine those together with multiplication. So log base b of x squared minus 2. There's your one logarithm. And you want to combine it with this logarithm. So you're having 6. Then the right side is still just the same. Log base b of 6x. Now what we can do is we can use the one-to-one property. What the one-to-one property says, if I have a logarithm on the left side of base b and a logarithm on the right side of base b, they equal each other. So I can drop those logarithms and just focus on the x squared minus 2 times 6, and then 6x. So I have x squared minus 2 times 6 on the left, and then I have 6x on the right. Now I'm going to solve this equation. So I want to distribute. So I have 6x squared minus 12 equals 6x. I want to get this into standard form. So I'm going to bring this 6x to the left. Set it equal to 0. I'm going to put it in standard form. So it's 6x squared minus 6x minus 12 equals 0. I'm going to take out the GCF of 6. So I'm left with x squared minus x minus 2. Now I use that t-chart method. What are the factors of negative 2 that add to negative 1? Well, that's negative 2 and positive 1. Now I set those factors equal to 0 and solve for x. So we get x equals 2 here, and we get x equals negative 1 there. Well, negative 1 again for a logarithm does not work. One example left. Suppose the bacteria culture starts with 1,000 bacteria. So this is my initial. That is going to be the A in this problem. Then it says it doubles every hour. So that's going to be my growth rate multiplier. So my growth rate multiplier is doubling. So that is 2. Then it says, how many hours will it take for the bacteria to exceed 6,000? So that is my end amount. So I'm going to go ahead and set up an equation and solve for the time. So again, the end bacteria is 6,000 bacteria. The initial in the problem was 1,000 bacteria. My growth rate multiplier is 2, and I'm raising it to the x power. Now we want to solve this equation for x. So the first thing we're going to do is we're going to divide both sides by 1,000. So 6,000 divided by 1,000 equals 2 raised to the x. Then 6,000 divided by 1,000 is 6. Now we want to solve for x. So what we can do is we can take the log of both sides. Just the common log is fine. And then if you remember that if I have this x, I can bring it down in front. So I have x times log of 2. And on the left side is still just the same, log of 6. And then the last step is to remove that log of 2 on the right. So I undo it. I divide both sides by log of 2. And I'm left with x. So remember, x represents the number of hours for this bacteria to double. So now we use our calculators. So we say log of 6 divided by log of 2. And we get x is approximately 2.5849. So we say then x is approximately 2.5 hours for this bacteria to go from 1,000 bacteria to 6,000 bacteria. This will be your assignment for 7.5 day 2. Good luck and have fun.